Terraform codebases often start simple, but as your infrastructure scales, they can become an unmanageable mess. In this video, I'm going to show you how to structure your Terraform the right way, using a modular approach for better scalability, security, and maintainability. Hi, I'm Jared. I'm a DevOps engineer passionate about building scalable and resilient cloud infrastructure. Today, I'm going to walk you through the power of modular Terraform, why it matters, how to use it, and some real-world code examples. By the end of this video, you will have all the tools and knowledge to start modularizing your own Terraform projects. Let's dive in. When starting with Terraform, a monolithic structure like this might seem straightforward. Everything is in one place, deployment is simple, and for small projects it works. But as infrastructure scales, this approach becomes a bottleneck. Here's what we're looking at. On the left, we have a typical cloud architecture, networking components, compute resources, even a storage layer. On the right, we see the Terraform file structure, everything packed into a handful of TF files at the root level. So what's the problem? Well, the issues start to pile up as environments grow more complex. When everything is defined in a few large, tightly coupled files, even small changes require redeploying the entire stack, increasing the risk of outages, complicating collaboration, and making debugging a nightmare. So while this structure might work early on, it starts to fall apart when trying to scale up efficiently. Let's take a look at what this same architecture looks like when we modularize Terraform. You'll notice that the Terraform file structure has changed. Instead of defining everything in a handful of TF files at the root level, we've introduced modules to separate key infrastructure components, network, compute, storage, and even tagging. So why does this structure make Terraform easier to work with? Well, each self-contained module can be reused across environments, enabling teams to work independently while isolating changes to specific components. This reduces the risk of any one change breaking the entire stack. Looking at our file structure, we can see that the modules directory holds our reusable Terraform modules. The TF vars directory stores environment-specific configurations, so we can apply the same infrastructure code across multiple environments. The files at the root of the repository act as the orchestrating components of our Terraform setup, managing module calls, configuring settings, and outputting key infrastructure data for downstream processes. So how do these modules actually work together? Let's take a deeper dive. Terraform modules don't exist in isolation. They're designed to work together by passing data between them using inputs and outputs. Let's walk through that flow. We start with the network module. This module is responsible for provisioning our VPC, subnets, and route tables, the backbone of our infrastructure. Once deployed, the network module outputs key networking details, the VPC ID so that all other resources know which network they belong to, and subnet IDs so we can assign compute resources to the correct subnets. Next, we move to the compute module, which provisions our EKS cluster and node pools. This module takes in the VPC ID and subnet IDs as inputs, ensuring that the cluster is deployed into the correct subnets for security and connectivity. The compute module then outputs the node group ARNs, which are needed for IAM policies and permissions in the storage module. Finally, the storage module provisions an S3 bucket and uses the node group ARNs to configure the correct IAM policies and ensure that our EKS worker nodes can read and write to the storage bucket. Each module builds on the previous one, ensuring that dependencies are managed correctly and our infrastructure is provisioned in the right order. Now let's take a step back and look at how everything fits together at the repository level. A well-structured Terraform repository isn't just about separating resources. It's about maintainability, scalability, and clarity. Here's how the key components of this repo work together to achieve that. First, we have our modules, the core building blocks of our infrastructure, each handling a specific function. Next is the environment variables. This is where we define configurations for different environments, allowing us to reuse the same Terraform code without modification. For example, a dev environment might use fewer nodes and smaller instances, while production would require more compute power and high availability. This approach keeps our code flexible, scalable, and easily adjustable for any deployment. Finally, we have the root files, the glue that ties everything together and orchestrates our configuration. With this structure in place, we now have a scalable, reusable, and maintainable Terraform setup. Now let's move into the actual code examples and walk through how each section of this repository is implemented. All right, now that we're inside the repo, let's walk through the code. I'll give you a high-level overview of the project structure, but for a deeper dive with a breakdown of each file and its components, check out my full blog post. The link is in the description. Okay, let's start with the modules. You can see that each module is self-contained in its own directory. If we jump into the tagging module, we can see that this group of files standardizes resource tagging across all deployments. It takes in a set of inputs, it combines those inputs into a map of tags, and then it outputs that map for use in the rest of our modules. If we come back to our modules here, we can jump into the networking module. This one defines our network layer. It is set up very much the same way. It takes in a set of inputs, and then defines all of its components. Each component is defined in its own file for simplicity. Our VPC file defines the VPC and Internet Gateway. Subnet file defines both of our subnets, public and private. We have our route table file that defines the public and private route table and then associates them with their requisite subnet. We also have our NAT gateway so that our private instances can communicate with the outside world. And then we output our necessary networking component information so that we can use that in our next module. If we jump into the compute module, again you can see the same pattern here. It takes in a set of inputs, and then it defines each of its resources and its files. In the EKS file, we have our cluster and our node group. If we come down to the IM file, this defines our cluster and node group role along with their policies. We also have our ingress file, which provisions our network load balancer, our application load balancer, and controls traffic flow, along with our security group file. This module also outputs its necessary component information for use in the next module. If we move finally to our storage module, this module provisions our S3 bucket and manages access. It takes its set of inputs and defines its components. Here in the S3 file, we define the bucket and several of its other configurations that are necessary. We also have the bucket policy. You can see here that this policy allows the node group ARN to perform the following actions against the bucket and its objects. Finally, this module outputs its necessary information for use in downstream processes. From there, let's jump into the TF-vars directory. This directory contains environment-specific configurations, allowing us to deploy the same Terraform code in different environments without modifying the core files. If we look at our dev environment, we can see we have our dev variables here, and the dev environment is going to have smaller instance sizes and fewer nodes, but we don't have anything defined here. That's because those variable definitions are defined at the root layer and set as our default. So dev is just inheriting the defaults, and I'll show you that when we get to the root of our repository. Let's go ahead and take a look at production. You can see the same set of variables set here, but you'll notice that we have compute variables set. We're going ahead and explicitly setting a larger instance size and a few more worker nodes for higher availability. If we come down to the root of our file and we start looking at our orchestrating layer, let's start here at the variables. These are the global variables that are inherited by each environment. Each one of these has a default setting and can be overridden if this variable is defined at the TF-vars level. If we come down here and look at our compute variables, you can see that the default is the T3 micro, and our default is just a single instance. This works best in our dev and our test environments. But when it comes to production, when we want more power and higher availability, we define that the TF-vars layer and override these values. If we move to our main.tf file, this is the file that calls our modules and passes in all of the necessary variables. You
You can see we're starting with the tagging module here and all of its inputs. We move down to the networking module where it has its inputs, but also it is ingesting the output of the tagging module. The same thing holds true for the compute module. It takes as inputs the output from the network module as well as the output from the tagging module. The same thing also holds true for the storage module. There's the output from compute module as an input as well as all of our tags. Finally, at the root of the repository, we have our provider and Terraform files. These files configure Terraform to use the AWS provider and sets up our backend for state management. All of these root files act as the brain of our Terraform project, coordinating our infrastructure components together. And that's how our modular Terraform setup is structured. The modules define our reusable infrastructure components. The TF-vars define our environment-specific configurations. And the root files orchestrate and manage our deployments.
Okay, now that we've walked through the Terraform code, you should have a solid understanding of how to structure your projects the modular way. If you want a deeper dive, I got you covered. Check out my full blog post for a detailed breakdown of every single file. The link's in the description. If you want some hands-on practice, clone my repository, tweak the code, see how it all works. Best way to learn is to get your hands dirty. But we're not stopping there. In the next video, we're going to automate Terraform with GitLab CI/CD. We're going to streamline our deployments. We're going to make our infrastructure changes seamless. Subscribe so you don't miss it. All the links are in the description. Hit that like button, drop me a comment so we can talk some Terraform. All right, that's it for today. Get out there and Terraform smarter, and I'll see you in the next one.